Today we are going to learn how to integrate with our inverse trig functions or our arc functions. It's the exact same thing that we took a look at with the derivatives. So what you need to do is memorize these derivatives. I also have a link to the integrals Quizlet on our Schoology page as well. So here we have a screenshot from the book with all of these integrals, the vast majority of which we know and have practiced for a while now. Scrolling down to the bottom, we will see some of those new ones with our arc trig. All right, so let's take a look at some of these patterns. Notice in the denominator, we have this a squared minus u squared. When we were taking the derivatives, this was a 1 because we were taking the arc sine of x times something. Now we may have the potential for x over a number. So whatever number squared minus our variable squared, the integral of that will give us the arc sine of u over a. Similar pattern here with our arctangent, a squared plus u squared will give us 1 over a times the arctangent of u over a. Again, we'll mostly be seeing these with x's. And same thing for our arcsecant. We've got that very similar pattern where we've got that u squared minus a squared, and that is part of our formula as well. Again, all of these integrals are on that Quizlet for you so that you can practice them and memorize them. All right, so our job is really just to figure out the pattern in order to get the correct integral. So I notice there's a square root in the denominator. 2 of my integrals had a square root in the denominator, the arc sine and the arcsecant. However, the arcsecant had an additional variable multiplied outside of the radical, so I know that this is an arc sine function. The other pattern I need to look for is that it was the square root of a squared minus, and I'll stick with u squared since we have x in our integral, and I don't want to confuse you with that same variable. I see that a is 1 because I have 1 squared minus, and then u is this entire quantity of x plus 1. So when I take the integral of this, the pattern was arc sine of u over a. Well, my u was that x plus 1, and my a was 1. And then, of course, that constant of integration plus c. So I'm just going to clean this up a little bit. Of course, dividing by 1 doesn't change anything. So we've got the arc sine of x plus 1 plus c. See, not so bad. We can integrate with our inverse trig functions. This one does not at first glance appear to match any of those patterns. So let's go back and take a look and see if we can't find a pattern that maybe kind of sort of fits what we're given. First of all, we had no radicals in the denominator, so that narrows my attention to our arctan function. Notice in the numerator, we have the derivative of u. I hadn't focused on that initially, but that's that chain rule piece of it. Or if we were going to let u equal, that could help us as well. Notice this pattern. And then in the denominator, we just have a squared plus u squared. So in the denominator, there's our a squared. So our a will be the square root of 7. There is our u squared. Our u is the cosine, and the derivative of cosine is negative sine, which very closely matches that numerator. We can easily take care of that negative value. So one option for integrating with our arc functions is to recognize the pattern. The second option would be u substitution. So I want to do it that way so that I don't lose anybody. We did notice this pattern. We're going to let u equal cosine of x. So when I take the derivative of both sides, as I mentioned, derivative of cosine is negative sine dx. All right, and we'll take care of that negative by just multiplying that out front when I rewrite the integral. Notice we've got this sine of dx, which is equal to du. So our entire numerator has been taken care of. And now in that denominator, we've got 7 plus u squared, which might be easier to see that arctan pattern. So integrating this, we will have negative 1 over a. Remember, a squared is 7, so our a will be the square root of 7 times the arctan of u over a. Again, a was our square root of 7 plus c. So there's our pattern for the integral of arctan. Now we can go ahead and replace that u with cosine. So if we were going to integrate this just by recognizing the pattern, again, squared in the denominator was our cosine. We had the derivative, or pretty close to it, in the numerator. We just needed to account for that negative, and our a squared was 7. So once you figure out what a and u are, you can simply sub them into that integral. All right, we do have a definite integral here. This one we're going to practice without a calculator because our goal right now is to get familiar with the integral of our inverse trig functions. This time I notice there is that variable out front and under the radical, that same variable. So I'm going to be using our arcsecant integral, and then this will give me my a value. Real quickly, we're going to revisit that arcsecant pattern. So we would have 1 over a. We recognize that our a squared was 4 in this case, so our a will be 2. And then for our arcsecant, we do have that absolute value. So we'll have the absolute value of x over 2, and then our plus c. Integrating, we get 1 over a, that's square root of 4, times the arcsecant of absolute value of x over a, which again was 2. We've got a definite integral from 2 to 4. Evaluating, we'll sub in 4 first. Of course, 4 is already positive, so we can go ahead and drop that absolute value. 4 over 2 minus 1/2 arcsecant of, again, same thing, 2 is positive, so 2 over 2. In order to evaluate these, we're going to use our arc cosine function. So we're looking for the arc cosine of flipping that 4 over 2, which is 2, we get 1/2. Minus, same thing for this one, we're going to flip this for arc cosine. Flipping 1, we still get 1. All right, take a minute to think about what angle gives us a cosine value of 1/2. Hopefully you came up with pi over 3 because cosine goes 3 to 1, so it's the larger angle. And then take a second and come up with the arc cosine of 1. What angle gives us a cosine value of 1? And that would be 0. As a reminder, when we're thinking about the range of our arc cosine function, arc cosine is the half sun on the unit circle. So our arc cosine function gives us values between 0 and pi only. All right, finishing this up, of course, 0 times 1/2 is still 0. So I'm just going to multiply those two fractions straight across, and I get pi over 6. I bet you can't guess what I am going to suggest that you do in order to help you learn these new integrals. That's right, use your Quizlet. Please, please, please use your resources. I tried to cut down the number of problems for you to practice because you have to watch the video and do your assignment. So in order to learn these, you've got to take some time and practice those Quizlets. Have a great day, and we'll see you again tomorrow.